be talking to you about automating the adjudication of insurance claims. So pretty much the first big project that we've implemented and the challenges that we faced. Okay, maybe I should talk a little bit about myself before getting started. My background is actually in mechanical engineering, and my first exposure to machine learning was for the application of controlling robots. And this was about 10 years ago. Since then, I've took on a couple of odd jobs, one as a professional poker player for a couple of years before starting at my first real job, which was here at Trupanion. There was not a data science discipline at the time, and I kind of built it from pretty much the ground up. Okay. This is a case study. This is how we did things, and my primary goal here is to generalize our experience and our findings so that it's useful to you. Okay. That's my primary goal. If I'm unable to do that, at least you'll get some value from the pictures of cute puppies and kittens that's all over our materials. Okay. Here's a quick outline of what I'm going to be talking about so you know what to expect. I imagine that not a whole lot of you are familiar with the pet insurance industry, so I'll be giving you a little bit of background there. I think there are some interesting properties that are interesting. Once we get through that, there are three main topics I want to cover. The first one is the modeling. How exactly did we model the kind of the human decision making that goes into adjudicating a claim? Okay. Second is the working from a data science team, working with an data engineering, IT deployment team, and the problems that arose and how we address them. And finally, we are going to talk about the human side of the problem. This is not a recommendation engine. We're not producing advice where a human will kind of take that advice and make a decision with it. We're literally automating someone's entire job, and there are implications to that, and we took great care to address those implications. Okay. All right, about us, Trupanion. We were founded 20 years ago in Canada by our current CEO, Daryl Rawlings. He leads about a team of about 700 workers, and we're a mission-driven bunch. We all love cats and dogs, and we have maybe about 200 dogs in our office. About 500,000 policyholders, and we're headquartered in Seattle. Okay, you might not think it, but the pet insurance industry is pretty big. It's $1 billion of revenue per 1% of penetration in the United States. Okay, and we're only at 1% market penetration. Only about 1 in 100 cats and dogs have health insurance. Compared to several countries in Northern Europe and the United Kingdom, they have 25%, 30% penetration. So our presentations to investors generally kind of highlight the upside. This could be a huge, $25 billion industry one day if we reach European adoption rates. Okay. One of the main barriers, in my opinion, to wider adoption is the current claims process. It's really clunky, and it's not a good experience for our customers. Okay, so imagine you have a pet and you have pet insurance. You go to the veterinary clinic and get some services done. This is what it would look like to get your claim processed. Okay, you would have to go to the receptionist, ask the receptionist to print out an invoice for whatever costs you incurred. You take that invoice home, maybe you log on to your provider's website, print out a claim form, fill it out according to the invoice that was printed out for you, and then send it in. Okay. Now on the insurance side, we now receive your claim. However, we can't process it right away. We actually have to request medical records from all of your previous veterinarians to kind of know whether or not the charges you've incurred are actually eligible. This process takes changes hands several times. It takes an average of 2 weeks. And in that 2 weeks, you have no idea whether or not your claim will be covered or how much will be eligible. Okay, this veterinary costs are constantly increasing, and it's not uncommon to receive a claim for $5,000, $10,000. With a recent implementation that Trupanion has deployed, we've written our own proprietary veterinary system management software that is installed directly in the clinic for about 1/3 of veterinary clinics, so about 8,000 out of 25,000 nationwide, where the receptionist can now submit the claim electronically right away. That will hit my automation systems, all the machine learning models sitting in AWS, and we'll have a response for the customer within seconds. So several weeks down to a few seconds cuts out the uncertainty of whether or not you're going to get paid, and you'll know the answer before you walk away from the reception desk. So, a game changer. Don't worry about, I don't want to spend too much time on the slide. This is kind of just defining the problem. Here's what a veterinary invoice looks like. It's kind of, compared to human medicine, it's the wild, wild west. There are no standardized codes, right? If you go and you get a procedure done, let's say here in New York City, you get the same procedure done in Miami, Florida. It's coded exactly the same way. Very standard, right? Not so in vet clinics. They literally free type their invoice items, okay? There's spelling mistakes all the time. They can charge whatever they want for it. And the medical diagnosis for this particular claim, I'm not sure you can see it, but it literally says, not doing it right. And of course, it makes sense, right? The dog's not going to be able to tell you, oh, I have a headache, or this hurts, right? So you wouldn't think that automating claims is an exercise in natural language processing, but it is. We have to account for all of that. And here's what the architecture of the models looks like. In the very beginning, the first prototype we built was just take all of the information that a claims adjuster needs to make a decision, just dump it all in, have one model that does everything according to our insurance policy, and at the very end, the output is pay this line item, pay this line item, deny this one, pay this one. So very big, complex model. Okay? And it was good for a proof of concept. Just how many claims can we automate? How many claims can we realistically expect to automate if we go forward with this project? Okay. Not scalable, right? It's easy to see that this model is not scalable. You can have multiple people working in it, and it's not modular at all. So we broke up that very big, complex model to several smaller, simple models. And the way that I model this is we're automating claims, but really we're modeling the human decision-making process, or really human thought process. And the way I broke it up is, I imagine it as a series of independent thought processes. Okay, so for example, we don't cover squeaky toys. Anything that's not medical related, we don't cover. Right? So if they buy squeaky toys or treats for their dog, right, that's not covered. And we also don't cover pre-existing conditions. So if the dog had a kidney disease when they signed up for the policy, kidney disease is not eligible for the lifetime of that policy. Okay. Squeaky toys and kidney disease are totally independent processes, right? When the human is looking at the claim and deciding if the claim is eligible, whether or not it's a squeaky toy and whether or not it's pre-existing, these thought models don't talk to each other. Okay, so for every independent thought process, I have an independent code repository and I have an independent model running that code. Okay. And I'm curious to think if I think that's generalizable to not just adjudicate claims, but this is a grand statement, but all thought processes. I'm not sure if that's true. But it works for us. Okay, now our code is modular. Now several people can work in several different repositories. The catch is, another advantage is we can parallelize these model calls, right? Rather than doing them one after another and taking a long time, we can kick off the processes all at once, and the total runtime is the runtime of our most complex, time-consuming process, okay? The only catch is we'll have to have a piece sitting at the end that collects all of these results from these smaller independent models and then actually do the thing that we care about, which is decide whether or not this claim is paid and how to write a denial letter if it's not paid and apply deductibles and all that insurance-y stuff. Okay. There's only 2 bullet points on this slide, but I'm going to spend a good deal of time talking about this. Okay, when we first conceived of this project, when I first conceived of this project and there was a prototype sitting on my computer, I had to go to the CEO and say, I think this can work. I think this project is going to change everything. I need resources to do this. I don't have access to live data. I don't have access to our claim systems that our people work in. Okay, I just need IT resources. I think it can be done in 10 days, okay? I have a model, okay? This model takes as input live data, and it gives you everything you need to actually automate the claim. 10 days, at worst, 100 days of IT resources. It ended up taking closer to 1,000 days. It took multiple years to actually deploy this model. And it's hard to overstate the magnitude of pain that caused me to make a prediction. I pride my, like, if nothing else, I'm good at taking data and making a prediction, right? My prediction was off by at least 1 order of magnitude, close to 2. Okay, so I thought long and hard about this, and the best way to communicate my findings is through a thought experiment. Okay, so let's say my partner goes to Home Depot and she buys a towel rack, and she comes home, shows me the towel rack, and asks me to install it. Okay, I look at it, I agree with her, I'm bought in. I think this new towel rack is way better than our old one. Holds more towels. You can flick a switch and it warms them up, right? That's awesome. I love it. Okay, what happens? A week later, I still haven't installed the towel rack. Why? I think the answer is ownership. Okay, if I were the one who had that idea and went to Home Depot myself to buy the upgrade or whatever, it would have been installed as soon as I got home. Okay, just because it was someone else's idea, someone owns that idea, it kind of disincentivizes everyone else from doing it. Okay, so if my life partner, the closest ally I have in this world, we share our interests 100%, can't motivate me to do my best work, then what chance do I have of motivating strangers who happen to work at the same organization, who report up through totally different verticals, to do their best work for 100 days? Right? It was an unrealistic expectation, and it was a kind of a rude awakening. Yeah, that's it. There's no shared ownership, and I don't think that gets talked about enough when we talk about data science versus engineering. I think it's a huge component. So we ended up using Domino Data Lab. I think one of the important properties of that is that it allows for transferring of responsibility to those that care the most, right? If, let's say, the project manager cares the most about that project, they can take over deploying the maintenance of models. If the data science team cares the most about the project, they can be the ones that own the maintenance of the models and the machines they sit on. And they're not paying me to say this, by the way. It just works for us. Okay, and here's the actual results of the model. We deployed it about a year ago in April, and now the blue line is what percentage of claims are we automating. We're up to about 30%, and now it takes about 5 seconds per automated claim. The reason why it's not 100% is we hold ourselves to a 99% accuracy. We're only allowed to make 1 mistake out of every 100 claims, and you guys should
understand this fairly well, but we get a prediction for pay or deny on every claim, right? We not only do we get a prediction, but we get a confidence. So we simply stack rank the confidence, and we go from the top down, like here are our top 1% of confidence claims, and we go all the way down to 30 until we reach 1% error rate. That's where we cut it off and say, this is the threshold. Anything below this threshold is no longer at 99% confidence, and that's where we get the 30% automation, okay? And I expect this to increase greatly with time. And the dollar savings is, it shakes out to about 400 claims per day, and the dollar savings is about $10 per claim. So what is that, $4,000 per day? That's not life-changing money. It's not nothing, but it's not huge, right? What is huge is the improvement in user experience, right? This will pave the way for much greater adoption of our product and pet insurance in general. Okay. All right, last, but in my opinion, the most by far important topic is that there are hundreds of people at our organization whose sole job is to adjudicate claims, and this is threatening their livelihood, right? So what was our strategy for addressing that? Okay, the strategy is simple. It's just listening to them, understanding their fears, and managing their expectations, right? A very common talking point I have is automation. We're automating the most simple, most repetitive, most uninteresting situations first, okay? All of the situations that require actual human, let's say, investigation, maybe it requires a phone call to the clinic, or it requires you to review records that are not electronically read in. Those interesting situations that activate your medical knowledge or your medical expertise, those will never be automated, okay? You will always have a place. And even if they do eventually get automated, if you are let's say, driven and effective, you will always have a place at our organization. Now, obviously, this particular conversation is very specific, right? The conversation I have with a claims adjuster is very different from the conversation that I'll have with, let's say, a trucker, if their job gets automated, right? But I think the general theme or the general approach to this talk is that you care. You care and you listen. It's a very basic human need to, speak and be heard. And that's all the people really wanted, in my experience. I'm sure most of you in this room can appreciate this, but humans are just excellent pattern recognition machines. If you don't give a shit, they can tell and they will hate you. And forget about doing the right thing. Even from a practical view, if you have hundreds of people hating you and rooting for your failure, there's a tangible difference in outcome than if you have someone who you've brought on your, like hundreds of people you've brought, onto your side, okay? That's about all I have. Before I open it up to questions, I wanted to mention that these are all beliefs I've had after I've put in like a non-insignificant amount of time and thought, okay? And if you have also put in a non-insignificant time and thought into similar issues and you have like a differing conclusion than I do, I would love to hear it if you want to reach out and we can discuss it and we can cooperatively seek truth together, okay? That's it. Thank you. Questions? Yes.
Can you talk a little bit about the logic of the model and like what sort of inputs you actually use
Sure.
the decision?
Yeah. Sure. Some of the models are very simple, like the model I mentioned to detect squeaky toys or things that are not medical conditions, right? We can look at the invoice as kind of a shopping list. We don't really need to know anything about human language. Okay, we can see this thing, the word squeaky toy are obviously a high signal value for this model that detects it. So we can kind of just do a simple text classification model where we just vectorize the words and put a tree-based model or whatever. So XGBoost tends to do the best in those scenarios. Okay, so and it's very wide-ranging. Every little model has its own quirks and unique challenges. So on the simple end, we just have text search. On the more complex end, when we're actually trying to interpret human language, where the veterinary will give us a description of what happened. Let's say yesterday the dog threw up and today they are lethargic or something like that. That actually requires an understanding of sentence structure and the English language pretty much. And for those cases, we tend to build more complex deep learning frameworks where there needs to be interconnectivity between words rather than detecting if something exists. Okay, so that's the crux of it. It's very wide-ranging, and we have the advantage of splitting up our models into smaller independent pieces is it allows us to go as specialized as necessary for every independent thought process. Yes?
I'm kind of curious, in your original display of the sort of, you had all of the sort of ensemble of models
Yeah.
all in one step and then a final conclusion. Do you ever have, I can imagine approval conditions in insurance where the output of one model has to feed into another judgment, and you can't just sort of put them all together at the end. Is that something you deal with right now?
Absolutely. So when one decision depends on another, it's no longer an independent thought process, and they do require to be on the same machine. So that code base is merged, and that does happen for several models. So that's what I was kind of alluding to when I said that the total runtime takes as long as the most complex thought process. Those ones have several different insurance-y steps that depend on the previous decision. Yes?
So I'm trying to understand a little bit the relationship you needed to have with your domain experts.
Uh-huh.
Kind of from an AI lens.
Mm-hmm.
In a more traditional AI application of this, with a lot of knowledge engineering, you'd have to have that relationship and garner all that expertise.
Mm-hmm.
In a machine learning mode, it would be more, here's a set of inputs, an invoice, here's the rendering of the adjudication of that. Let machine learning just have at it with enough training samples.
Mm-hmm.
You spoke a lot, though, of needing, so to what extent did you need to get domain expertise from your subject matter experts then?
A lot.
That's the piece I'm a little confused about, given, were these models trained models, or were they engineered models through more traditional knowledge engineering? Or a combination?
So it is a combination, but the involvement of domain experts was huge. I spent probably somewhere between 30 and 50% of my prototyping time working with someone who really knew the process, right? We need to know exactly what goes into the mind of a claims adjuster so that the model has a fair shot at it. The model needs to see every piece of information that the human sees, and it's not just the invoice, it's also pet history, past communications, past decisions that were made by other claims adjusters. All of that information lives in a different place.
So it was more getting all the inputs that go in versus the logic?
The logic would be the component that is mostly handled by machine learning, right? So the adjusters will read our policy, our insurance policy, and make decisions according to that. Our models have no concept of an insurance policy, what it is, what the wording in it means. Everything that it knows about adjudicating claims is based on past decisions of adjusters. So that part is the machine learning. Yes?
To your point, so you said you worked a lot with a domain expert, of essentially someone who really knows that process.
Mhm.
Did you guys find, so obviously you're automating that, but was it just take the process as it is and simply replicate that in model form, or did you find that you guys were actually making changes to that process?
That's a great question. Making changes to the, starting out, I think we made the call to not change anything. We just worked with what we had, okay, just to prove to everyone that we could. Now that we're automating a significant percentage of claims, I think we're gaining enough political capital to start making proposals. Like, this process is preventing us from automating more claims, and it probably is in the way of the adjusters doing their work as well. We're not quite there yet, but I think we're very close to being able to suggest improvements and having them be accepted.
But without this in place, that would be,
It's just a kind of a judgment call, right? It'd be a lot to ask for such an untested product. I just didn't think it would go over very well. Yes?
So 2 questions.
Sure.
Are you looking at any kind of machine-assisted claims for the other 70%?
Yes, absolutely. That was supposed to be step number 1, to actually surface predictions and kind of color code confidence and have the humans assist in the learning, right? It'll get our less confident claims over the threshold. Our CEO just stepped in and made a judgment call and said, no, we're not doing that. We're going straight to automation, and that was it.
And how are you picking the 1%? Is someone scoring your decisions, or is it all kind of derived out of the stats?
How are we handling the 1%? Oh, that's also a good question. I didn't really get into details of how everything works, but before we push models to production, we have 2 parallel streams, a production stream and a test stream. The test stream is the candidate to become production. It's the one that will have all of the improvements. We keep that running for about a week or 2 till we get thousands and thousands of predictions, and we match those up to the actual adjuster decisions. So we have a pretty good reality versus what's going to be the new reality. And that's where we get the 1%. It's no longer practical for us to have eyes on every claim that we actually automate. We can't look at 400 claims per day. So now we rely on the traditional QA processes that the claims department already has in place to kind of making sure that the humans are doing their job correctly. Yes?
I'm trying to wrap my head around something. So for the 2 tests who, for which you evaluate the claim, they have the same pre-existing conditions, whatever.
Mm-hmm.
For the same line items,
Mm-hmm.
you get the same result. Is that correct?
Yeah, if everything is the same, it's a stateless model.
Right.
Yep.
So if you didn't have the NLP problem, that just a free text form,
Mm-hmm.
if you had the codes, then that would be. Would you say that would be a pretty straightforward answer? Because it's like, you know what goes in, and you know exactly what they charge for, and you can tell exactly if it needs to be educated or not without having to learn anything really, other than those rules. Right? Is that correct?
I think so, yes.
Okay.
I think that's correct. I would say, so there's a layer of uncertainty that's introduced by NLP, right? We're just removing that multiple.
If that were a result, like if you had codes, like if you have
Correct.
codes, right?
You'd be removing a source of uncertainty.
Right, but like if you had codes, like you had for human,
Yep.
Claims,
Mhm.
then that would be more straightforward, right?
Oh, absolutely.
I guess moving from that, my question is that what if the industry goes towards there,
Mhm.
and like now it's a free text, and then industry goes toward a place, maybe like it did, I don't know the history of human insurance.
Yep.
Things, maybe it started with free text and then moved into more standardized. If the industry moves you're kind of assessing a lot of uncertainty, which is very valuable.
Mm-hmm.
But what if the industry takes it away? Then it's like, then it's a simple, rule thing, right? And for this case, you cannot claim this thing.
That is only partially true. Okay, so I didn't really get into details of how our policy works, but imagine a case of pre-existing conditions, right? We have a medical history that's unstructured, and we have a claim that's loosely related to this history, and the human kind of makes the call. Like, let's say in your medical history, your dog has come in and kind of scratched itself more than normal, and the vet notes that down. Now, 2 years down the road, you file a claim for skin allergies. There's a lot of judgment that goes into that that's deeper than just text classification. You have to have like a model that replicates. So all of our claims adjusters have medical knowledge. They are the equivalent of nurses in vet offices. We have to have a way of replicating that knowledge of being a technician, okay, which kind of goes beyond NLP. Yeah, it'll certainly be easier.
Yeah, I have no idea like how those things work.
Yeah.
So I'm glad you clarified because that makes sense.
Sure. Maybe one more question. My timer says 0.
My domain knowledge is healthcare, so even
Sure.
though we have comprehensive coding, it's extremely inconsistently applied. So even if the industry was to fully implement coding, like
Yeah.
we have in healthcare, it still would not. Hospitals, practices, they all implement the codes somewhat differently, so you wouldn't have a fully deterministic solution. So.
Yeah. Maybe one more, and then they'll probably kick.
So how often do you have to go through and take a look at your models and see if like they need retraining or refreshing or the
Yeah. We have a dashboard that kind of looks at it, that kind of characterizes model drift. And when we arbitrarily say, oh, it's time, then we rebuild it. It happens about every month or two.
And is that more frequent for the more complex ones, or do they all get the treatment about the same time, or?
Oh, good question. We like to, because of the piece at the end that aggregates all the results of all of the models, we do have to go through and retrain everything, which eventually we want to automate that process, but right now it's still pretty clunky and complex, so we do it manually. Cool. Thank you, everyone.